Okay, welcome back, students. Let's go over section 2.5, further applications of right triangles. So section 2.5 talks about something called the bearing. So this refers to the direction of an object. Okay, there are two ways to express bearing, and comes from navigation. So it's a bearing and a heading. Okay, are navigational terms. So bearing, given a single angle, the bearing is measured from due north. So there's two different ways you say, hey, I'm due north, and then I want a certain angle from north. Okay, or if you're given whether it's north or south, then it's followed by an acute angle, either east or west. Okay, and we'll get into what this looks like. Okay, so let's look at a bearing of 25 degrees. What does a bearing of 25 degrees look like? Well, if it doesn't tell us if it's north or south, we assume it to be north, and then we go clockwise. Okay, so it's a little different in that we start off north. Okay, given a single area, the bearing is measured clockwise. Okay, the opposite direction than what we're used to, clockwise from north, and then we go in. We take that angle clockwise 25 degrees. Okay, so that's a bearing. So it's a little different than how we've been measuring angles, because we've been doing them counterclockwise. Okay, and we start from the x-axis. So a bearing of 200, what's that going to look like? Well, that's going to go, so if I were to start at north and go all the way to south, that's 180 degrees. And so we're going to continue a 20 more degrees. Okay. And so if we look at our axes here, okay, if we go all the way around to 220 or 200 degrees clockwise, that's an extra 20 degrees from 180, then we end up down here. So and this just gives us the angle. It doesn't give us the length or the magnitude of how far we've gone. It's just gives us the angle that we're looking at. Okay, it's the bearing or the heading. Sometimes they call it heading as well. Okay, so a bearing of north 36 west. What does that mean? North 36 west. Okay, so north, right? But instead of going east, remember this is north, east, south, and west, right? So on a compass, never eat soggy waffles. Okay, that's a mnemonic device that they sometimes use going around. Clockwise, never eat soggy waffles. Okay, and so north, east, southwest, but instead of having a bearing of just 36 degrees, which would mean that we would go in the clockwise direction, we're actually going to go counterclockwise because it tells us to go west. It's a bearing west of 36 degrees. I made that angle a little too big, but it's a bearing west of 36 degrees. Okay, from north. What about the other one here? Here they tell us to go south. Okay, they tell us to go south first, so our orientation is south, and then it's 52 degrees east. Okay, so east is over here, so I'm going to start here, and then the angle goes here, 52 degrees. Okay, east, and that tells me to go toward the east in a counterclockwise direction. Okay, so it is a little tricky. Hopefully with a little practice, you'll be able to figure it out. So let's do a couple examples using this. Okay. Okay, radar stations A and B are on an east-west line. Okay, well, that's good. Okay, so east-west line. So this is west over here. This is east. Okay, and radar station, we're going to say A and B are on an east-west line. Okay. And they're 86 kilometers, 8.6 kilometers apart. So 8.6. So 8.6 kilometers. Okay, maybe I'll highlight that. That's 8.6 kilometers right there. Okay, and it's saying station A detects a plane at C on a bearing 53 degrees. Okay, so station A has a bearing of 53 degrees, and that's a 53 degrees from north. So let's draw our north-south line here at A. And so we're going to go 53 degrees. Okay, 53 degrees from north. Okay. So that's that angle there. Okay. And we'll just put C here. We don't know how long it is yet, but we'll just put C there. Just okay. I'm gonna get rid of that. This is 86, 8.6 kilometers. Just write that like that underneath, because the triangle we're gonna build is actually gonna be above. So I'm gonna erase that. Okay, so station A detects a plane at C on a bearing of 53. Okay, station B simultaneously detects the plane on a bearing of 323 degrees. Okay, so 323 degrees, that's almost 360. So if we start at north and we go all the way around, we would be at 360, but we're just shy of that. We're about, I don't know, what, 37 degrees shy of 360. So, okay. So they're saying that A detects it at 53 degrees, B detects it at a 323 degrees, 323 degree angle there. Okay, this would be 37 degrees right there. Okay, so what's interesting, okay, and how did I get the 37 degrees? I just did, you could do 360 minus 323 is equal to 37 degrees. Okay, so that's how I did that, because all the way around would be 360, and so I just shaved off, I subtracted the 323, and that's the 37 degrees is this guy. I'm going to put him in blue. Okay, that's 37 degrees. Okay, now let's get the angles of our triangle. We just built a triangle, and so we want to get the angles of our triangle. Okay, this guy is B, this guy is A. I don't want to lose those guys. Okay, and so what's this angle going to be? Well, that angle is going to be 90 minus 53. Well, what's 90 minus 53? Well, that's 37 degrees. Okay, that's nice. 37 degrees. And then if this is 37 degrees over here, let me highlight the other 37 degrees. Okay, right there. Then the complement of that, or this angle here, is going to be 90 minus 37, which is 53. So this is 53 degrees. Okay. And I noticed that 37 and 53, they are complementary angles. They add up to 90. And so if those two angles of the triangle, the base angles of the triangle add up to 90, then this angle also has to be 90. So that's a right triangle. Hallelujah. We have a right triangle. Therefore, we can do some right angle trigonometry. A right triangle trigonometry. Okay, so what are we really looking for here? Well, I'm going to put this in black, what we're really looking for. We're really looking for this side of the triangle from B to C. Okay, that side of the triangle from B to C. Okay. So how am I going to do that? Well, I have the angles and I have the hypotenuse. Remember, this is the right angle is C. Okay, at point C. Okay, we have this right angle. We could call that angle C. And so that's a right angle. And so we have the hypotenuse here of 8.6 kilometers. And we want to find this side BC. Okay, the side BC. Well, we have all the angles. And so we could easily use maybe this 37 degrees to get the opposite over the hypotenuse. And what's opposite over hypotenuse? Yeah, that's sine. So we could say the sine of 37 degrees is equal to the opposite, which is what we're looking for. I'll call that x. Okay, that's the opposite. You could call it little a too, because it's opposite angle A. Maybe we'll do that. Okay, it doesn't matter. It's just, we'll call this x, side x, BC. Okay, and so it's going to be x over the hypotenuse of 8.6. So now I can cross multiply. Okay, and I get x is equal to 8.6 times the sine of 37 degrees. And then we're just going to plug that into the calculator. Okay, so 8.6 times 30, the sine of 37 degrees, the sine of 37 degrees. Okay, and I'm getting 5.17. I'll round it to 5.2 because we were given 8.6 to 1 decimal place. And so that's 5.2. So 5.2, and then it's in kilometers. Okay, that's how far B is, station B is from, okay, the plane at C, at point C there. Okay, that's how far, and we could figure out how far A was from C if we really wanted to by doing the exact same thing, but just using the other angle. We would use the 53-degree angle instead of the 37-degree angle. Okay, but the problem didn't ask for that, so I'm not going to do it. Okay, example 15 is a little bit more complicated. It says a ship leaves port and sails on a bearing of south 34 degrees west. Okay, so south, okay, 34 degrees west. So west is over here. Okay, so south is here and 34 degrees west. Okay, so this guy here, okay, is 34 degrees west. Okay, and for 2.5 hours. Okay, we'll get to that 2.5 hours in a little bit. If it then turns and sails on a bearing of north 56 west, okay, so then from here, okay, it turns and goes north 56 west. Again, west is over here, north is over here, and then it turns, okay, and goes northwest. And we always do the angle. We always start the angle from the north-south line. Okay, so this angle here is going to be 56 degrees. Okay, 56 degrees there. Now, one thing to notice, okay, is that wherever this guy, and then this guy goes 3 hours. Okay, wherever this guy ends up, it's going to make a triangle. So I'm going to close the triangle here. Okay, like so. Okay. Because that's going to give us the distance from where we started to where we ended up, from our origin, okay, to our final position. Okay, and one thing to notice is that we have parallel lines here. Okay, the first, compass orientation gave us a north-south line, and the second compass orientation gave us another north-south line. And so when we have parallel lines cut by transversal, alternate interior angles are equal. So this is a 34-degree angle as well. Well, what does 56 degrees plus 34 degrees add up to? Yep, you guessed it. It adds up to 90 degrees. Okay, so that's a 90-degree angle there. which gives us a right triangle. Very good. I want to find, okay, the hypotenuse, okay, of this right triangle. Okay, well, I need the sides of the right triangle. So how am I going to find the sides of the right triangle? Well, if I know that I'm going to talk about distance here, distance equals rate times time, right? Okay, and so it says the ship's rate is 18 knots. Now, a knot is a nautical mile, okay, and this knot is a nautical mile, which is different than a regular mile. A nautical mile is a little bit longer, and simply because they don't use the mile that we think about when we're driving in a car. We don't, or walking on the earth, on the land. Okay, we don't think about that mile. That mile is a set amount of distance, okay, relative to just an arbitrary distance that they said, okay, this is a mile. It was, I think, early on in you know, medieval times, they said, well, it's about what a cow or an oxen can pull, okay, can plow, I think, in a day without, you know, getting completely exhausted. So they were like, oh, it's about a mile, right? So they can plow that field about a mile, okay? But when we started navigating the earth with ships and sailing the globe, we started using latitude and longitude, and what a nautical mile ends up being is a nautical mile is equal to 1/60th. This is 1/60th of 1 degree latitude. Okay, so it's 1/60th. It's basically 1 minute on a globe. So 1 minute is 1 nautical mile, and it just happens to be that 1 nautical mile is equal to 1.15, okay, land miles. Okay, so it's pretty close. It was pretty close. You know, the amount that an oxen can pull, can plow in a day, and the amount that's 1 minute, okay, or 1/60th of 1 degree. Well, what's 1/60th of 1 degree? That's a minute. 1 minute of latitude, 1 minute of latitude is 1 nautical mile. So interesting. You don't really need to know that to do the problem. Just wanted to give you a little bit of background on that. But the rate is at 18 knots, and a knot is a nautical mile. Okay, so the rate is 18 knots, and then we first went 2.5 hours, right? So 18 times 2.5, okay, what is that? 18 times 2.5 is 45. So we went 45 nautical miles. We went 45 miles. Okay, so a knot is a nautical mile per hour. Okay, this is, I should say, nautical mile per hour. Okay, that's what a nautical mile is. Okay, and so, or sorry, a knot is a nautical mile per hour. A nautical mile is just a nautical mile, but a knot, K-N-O-P-T, is a rate. It's a nautical mile per hour. So this was, I think it was 45 knots, okay, or sorry, nautical miles, because we canceled out the time, canceled out the hours. So I'll put NM for nautical miles. Okay, so 45 nautical miles is here. So I'm going to put this in a different color because it's getting confused. I'm going to put this in orange. Okay, so 45 nautical miles, 45. So we first went 45 nautical miles in a southwest direction. Okay, what about on the second part of the journey? Second part of the journey, we're going to do 18 knots times 3 hours. Well, 18 times 3 is 54. So that's going to be 54 nautical miles. Okay, and so we have So we have now 54 here. And so we have the sides of the right triangle that we're looking for. We're looking for a squared is equal to b squared equals c squared. A squared, sorry, plus b squared is equal to c squared. And we have 54 squared plus 45 squared is equal to c squared. So it's equal, c is equal to the square root of 54 squared plus 45 squared. And so c is equal to approximately what? Okay, so we want the square root of 54 squared plus 45 squared is about 70.3 nautical miles. I'll do 70 point, I don't know, 29. What did they give us? They didn't give us anything. Maybe 70.3. I'll just round to the nearest hundredth of a nautical mile. So this is 70.3 nautical miles. Okay. It's really weird. Okay, and that's application section 2.5. I will see you in the next video. Thanks.